Hello, students. Welcome back. We are working on our notes 26, and this lesson is about solving systems of equations using a new method called substitution. Now, I wanted to remind you what systems are. So, systems are where you have two equations. So, you'll see I'm hovering over x equals 2y, and then a second equation, x plus y equals 12. In our last lesson, we learned to solve these by graphing. So I just went ahead and used Desmos and took those same two equations, x equals 2y, x plus y equals 12. And I could say that I've already solved it by graphing and looking at the intersection point. But there is another way that we can solve these systems of equations, and that's what we're going to look at today. So this method is called substitution, and it's nice to use when you have one variable that is either already by itself or is easy to get by itself. So you'll see in this worked out example that I have x equaling 2y. So I can take that expression for 2y, replace it in my equation x plus y equals 12, replace the x with that, and then now I've got my equation to where I have just one variable. So then I could solve 2y plus 1y makes 3y. I could divide both sides by 3 and get y equals 4. Now, as you saw in Desmos, the solution is an ordered pair. So I only know the y right now. I can substitute that value into either equation. And so I could substitute into the x equals 2y. And if I do that, then I get x equals 2 times my y value, remember, was 4. So 2 times 4, x is 8. And notice that I get that ordered pair, 8, 4. So now we're going to run through the process, working a problem out together. So one thing that I like to do as I'm working on a system of equations solving by substitution is to write the two equations side by side. So you'll notice that oftentimes they're presented to you stacked up. I have one equation, y equals negative 4x plus 12, and then my second equation, which is y equals negative 2x plus 2. So I have them written side by side. And now I'm going to take one of these equations, and since I have, for example, this first one already solved for y, I can take this expression, negative 4x plus 12, and replace it into my other equation in place of the y. And so I'll take the y out and make my substitution negative 4x plus 12. So that replaces my y. That's going to equal, and then I'll keep my right-hand side, negative 2x plus 2. This gives me a chance to solve my equation. So here is my equal sign. I can add 2x to both sides of the equation. That'll give me negative 2x plus 12 equals 2. And then I would need to subtract 12. Here's my equal sign again from both sides of the equal sign. Now I have negative 2x equals negative 10. And then I can divide both sides by negative 2. And that's going to cancel my negative 2's to get x equals, and I have a negative divided by a negative. And so I have an answer of 5. Now, I have to remember that my answers should be ordered pairs. So I have found half of my solution. I now need to find the y value that goes with this. So I can substitute my x equals 5 into either equation. Since I've got space to work with my first one, I'm going to work with this one. So I have y equals -4, and then I found my x value to be a 5. So I'll substitute that in, and then the rest of my equation is plus 12. So y equals, now you can use Desmos if you need to. -4 times 5 is -20. And so I have -20 plus 12, and y equals -8. I have both my x and my y, and so my ordered pair solution, putting the x first, would be 5, and then my y, -8. Remember that your solution is the ordered pair that would make both equations true. So I could check by substituting in 5 for my x and seeing if I get -8 for my y, and I do. And it has to work in both equations. So if I substitute 5 in here, -2 times 5 is -10 plus 2, and that's -8. Another thing that you could do is you could use Desmos. You could type in your two equations. So my first one was y equals -4x plus 12. And then my second equation was y equals -2x plus 2. And then I could look to see if my two equations intersect at 5, -8. And so I'm going to have to take the keyboard down here, and they do. So that would be another way that you could double check to see if you have the correct solution. So we'll move on back to our examples. I do have an answer blank for the solution. I'm going to go ahead and put my answer there. So 5, -8. All right, for example number 3, I think I'm going to clear the ink so that I have a clean space to work. For example number 3, I have my two equations. I have 2x minus y equals 8. I have y equals 2x minus 3. For this method, I like to write them side by side. So you'll see 2x minus y equals 8, y equals 2x minus 3. All right, so now I'm going to do substitution. Some of this is about making good decisions. So I have an equation right here that already has a variable by itself. I have y equals. So I can take the expression 2x minus 3, I can take that part of the equation, which is equivalent to y, and substitute it in place of the y in my other equation. So I'm going to do that now. I'll have 2x minus, now because I'm subtracting, I've got to be careful that when I substitute for the y, I use a parentheses. So 2x minus 3 is going to replace the y. And then I have the rest of my equation equals 8. So now I just need to remember that I will need to get rid of my parentheses. So having a negative sign in front of the parentheses, sometimes it's easier to write that as -1 so that I remember I'm distributing -1 times 2x, that would be -2x, and then I'm distributing -1 times -3. And so that would give me +3, and then equals 8. So as I solve this equation, I find that something unusual happens. I get 2x minus 2x, and that's 0. The 2x's cancel out. So now I have this statement, 3 equals 8. And 3 equals 8 is not a true statement. So I've got this little box over here that I'd like for you to pay attention to. It says if the variable cancels, the system will either have infinitely many solutions or no solution, depending on if the remaining equation is true or false. Well, the equation that I have is false. 3 does not equal 8. So no solution is what happens when I have that false statement. So in the solution blank, I would like to write no solution for this one because I ended up with a false statement. Now, I do not have another example to show you, but if I would have ended up with a true statement, then in the answer blank, I would have written infinitely many solutions. So those two things happen when the variable cancels. And that's what happened in this problem right here. The 2x minus 2x canceled out all of my variables. So because I had a false statement, no solution. Okay. Again, you could take your two equations, look at the graph of those, and see what happens with that. So I'm gonna go ahead and take us to Desmos and just look at it. So my one equation was 2x minus y equals 8. And my second equation, if I go back and look, was y equals 2x minus 3. And so what you'll notice is that I have parallel lines, and we found that when we graphed parallel lines, they were never going to intersect, and so our solution is no solution, and that's what we found when we did our substitution method. Okay, I'd like for you to move on to example number 4. And in this example, we have a word problem. So we're going to try to follow a little procedure for solving word problems. First, read the problem. The sum of two numbers is 21. Their difference is 13. What are the two numbers? So I like to have us start off by defining what it is we're looking for. And those are our variables. Usually that's indicated with the question mark. What is the question? So what are the two numbers? Well, we can use an X to represent the first number, and we can use Y to represent the second number. So we're looking for two numbers. And then we have two statements. Our first statement says the word sum. That means addition. So we're adding our two numbers. Is means equals, and it equals 21. So we could take our first number, add it to our second number, and that equals 21. X plus Y equals 21. Our second statement says their difference. So their meaning the two numbers. Difference is subtract. Is means equals. So we'll take our first number, subtract our second number, and that's going to equal, and it says 13. So their difference is 13. All right, so I already have my two equations written side by side. So now, in this situation, I do not have one variable that is already by itself, but I could easily take either equation and get a variable by itself. So I'm going to work with my second equation, the red one, and I'm going to work to get this x by itself, which means that I would need to move the y to the other side of the equal sign. So I'll do that by adding y to both sides of the equal sign, and that's going to give me x equals, so these are gone, and now I can't really add 13 and y, so I'm just going to write it as y plus 13, or you could write it 13 plus y. All right, now I'm going to take that expression and substitute it into my other equation in place of the x. So the x will come out, and y plus 13 is its replacement. But I still have the remainder of the equation, so I have plus y equals 21. So I've made my substitution. Now I'm going to solve my equation. I have like terms. I have 1y and 1y. I can add those together to get 2y plus 13 equals 21. I now need to find my equal sign. 13 needs to be subtracted from both sides. That will cancel out the 13. I'll have 2y equals, and then 21 minus 13 is 8. And then I'm going to undo my multiplication by dividing. So I'll divide and get y equals 4. Now remember that our answers are to be ordered pairs. We're supposed to find both x and y. So I have found the y. I can now take this and substitute it in place of the y in my expression x equals, and then in place of the y, I could put my 4 that I found. So 4 and then plus 13. So x would equal, and 4 plus 13 would give me 17. Now, normally we write our answers as ordered pairs, but this is a word problem, so I'm asking for a sentence answer. Here's my question. What are the numbers? So state back the question. The numbers are, and then state what your two numbers are, 17 and 4. 17 and 4. And then end your sentence with a period. So we have that kind of word problem that you will probably run into. And then we have one that is a little bit more application based. So I'll move up to let us see that one. Example number 5, your last example, says to write a system of equations and solve for the indicated values. So as we read the problem, it says online tickets for a concert cost $10 each, plus a service charge of $8 for the order. Tickets at the door cost $12 each with no service charge. For what number of tickets is the cost the same, and what is that cost? So we find that we have our question right here. So we could let x equal our number of tickets. That's the first question that's asked. And then we could use our second variable, y, to answer the question, what is the cost? So the cost of the tickets. Now, in a cost equation, very often you have the cost equaling. So in other words, y in this problem equaling and then something happening with that. So let's look and see. In this first sentence, it says the cost is $10 each. So each usually means multiplying. So we're having $10 multiplied by every ticket that we order. And then plus, so we're going to add to that a charge of $8. So we've got to remember that we're taking 10 times our number of tickets. Well, we don't know our number of tickets, so that was the variable x. So 10 times that number of tickets x, and then plus a service charge of $8. So there would be our first equation. And then our second equation, tickets at the door will cost $12 each. Here's that each again. So that's a multiplication, but it's multiplied by your number of tickets, which is what you don't know. So your cost, y, would equal $12 for each ticket, and then it says no service charge, so nothing to add on. All right, so I have my two equations written side by side. I have a situation where I have both equations as y equals. So I can take either one. I'm going to work with this one, my 12x. I'm going to take it and substitute that in place of the y in my other equation because y is 12x. So I can replace y with the 12x and then have that equal to 10x plus 8. And now I can solve that equation. Here is my equal sign. I can subtract 10x. I need to get my x's on one side of the equal sign. So 12x minus 10x, that would be 2x. These are canceled. 2x equals 8. And then I have to undo my multiplication by dividing. So I'll divide by 2 on both sides of the equal sign and get x equals 4. So 8 divided by 2, x equals 4. Now that I know x, I can substitute that into my other equation. So y equals 12 times, and my x substituted in would be a 4. And so y equals 12 times 4, and 12 times 4 is 48. So once again, because this is a word problem, I would like a sentence answer. We'll answer both of the questions that were asked. So the first question that was asked is, for what number of tickets is the cost the same? So the cost is the same for, all right, now I needed to know X was my answer for my number of tickets, so that would be this one. So for 4 tickets, and then it asked, what is the cost? The cost is, and that's my Y value, and it's money, so we should use dollar sign, $48. So the cost is the same when you buy it at the or online as when you buy it at the door when you buy 4 tickets. And that cost that is the same whether you buy it online or at the door is $48. So again, this is the substitution method, and it is a second method that we use for solving systems. This will be a good time for you to review and to brush up on your equation solving skills. So don't hesitate to ask for help as you need it, showing complete work as you solve using this method.